Now some important points related to the photoelectric effect. The first is threshold energy. What do you mean by the threshold energy? As photoelectric effect is the removal of the electron from the surface of the metal, and we know that there is force of attraction between the nucleus and the electron. Therefore, whenever we supply the energy in the form of packets or in the form of the bundles, then that energy is used to overcome the force of attraction between the electron and nucleus. As there is force of attraction between electron and nucleus, when we supply energy from the outside, that energy should overcome this force of attraction. Whenever the energy that we supply from the outside is greater than or equal to this force of attraction, only then this electron will remove. Otherwise, this electron will not remove from the surface. And that energy, that minimum amount of energy that should break this force of attraction, that minimum energy is known as threshold energy. Hence, we define the threshold energy, the minimum amount of energy, that we require to break force of attraction between most loosely bounded electron and nucleus. The minimum energy that we require to break this force of attraction, that energy is known as the threshold energy, and that energy can be calculated as h nu naught, where h is the Planck's constant and nu naught is known as threshold frequency. If the radiations which we supply from the outside, that radiations don't have this frequency, then it is not able to break this force of attraction and electrons were not ejected or electrons will not ejected. Next is if we supply the extra energy from the outside, or the energy which we supply from the outside is greater than the threshold energy, then extra energy converts into the kinetic energy of the electron. It means the total energy which we supply from the outside is used into two parts. First, it is used to break up the force of attraction between the electron and nucleus, that is known as the threshold energy. Then, if this energy is greater than threshold energy, then extra energy converts into the kinetic energy of the electron. This threshold energy is also known as the work function of the radiation. This threshold energy is also known as the work function. Why it is known as the work function? As this energy is used to do the work. What type of the work? To break up the force of attraction between the nucleus and the electron. This energy is used to do the work. What type of the work? To break up the force of attraction between the nucleus and the electron. Therefore, it is also known as the work function, and the extra energy that we supply from the outside is used into the kinetic energy of the electron. Hence, it is written as E. E is equal to W naught. W naught is the work function over threshold energy, and the extra energy is used into the kinetic energy. Therefore, it is written as E is equal to H nu naught plus half mv square, where H is the Planck's constant, nu is the frequency of the radiations which we supply from the outside, nu naught is the threshold frequency, m is the mass of the electron, that is 9.1 into 10 raised to power 31, and v is the velocity of the electron with which it moves from the outside of the nucleus. Now, when we solve this, it comes out to be h nu minus h nu naught is equal to half mv square. H is common, nu minus nu naught is equal to half mv square. This is the mathematical expression for the photoelectric effect, where nu is the frequency of the radiation, nu naught is the threshold frequency, m is the mass of the electron which is 9.1 into 10 raised to power minus 31 kilogram, and v is the velocity of the electron with which it moves. Nu is the frequency of radiation, nu naught is the threshold frequency, m is the mass of the electron, v is the velocity of the electron, and last one is the h. H is the Planck's constant, its value is 6.626 into 10 raised to power minus 34 joule second. Next, what is the effect of the radiations on the electrons or the kinetic energy of the electron? It is find that the frequency of the radiations is directly proportional to the kinetic energy of the electron. Means, higher the frequency of the radiations, higher is the kinetic energy. If we draw the graph between the frequency of the radiations and kinetic energy of the radiations, it is find that higher the frequency, higher is the kinetic energy of the radiations. Secondly, it is find that kinetic energy is independent from the intensity of the radiation. Kinetic energy of the photoelectron is independent to the intensity. If we plot the graph between the intensity and kinetic energy, as kinetic energy is independent to the intensity, therefore we have a graph like this. This parallel line shows that the kinetic energy of the photoelectron is constant, or it does not depend upon the intensity of the radiations, but the number of the photoelectrons depends on the intensity of the radiations. Higher the intensity of the radiations, higher is the number of the photoelectrons. If we draw the graph between intensity and number of photoelectrons, it is find that the number of photoelectrons are directly proportional to the intensity of the radiations. Higher the intensity, higher are the number of the photoelectrons that are ejected from the surface of the metal. This is all about the photoelectric